So this one is May-June 2020 paper 6 variant 1. A student investigate the balancing experiment. As we did the first part, we have to just write 1 over x. So that is 0.025. This value was 0.025. Then 0.037. Then we have 0.050. And we have 0.063. And then the last one 0.075. These are the values for 1 over x. The next part, we have to plot a graph between p and 1 over x, where p is a load and 1 over x. So that is 2.0 or 2, we can say 3.0 or 3, 4.0, 5.0, and 6.0. And the 1 over x is 0.025, 0.037, 0.050, 0.063, and 0.075. These are the values for 1 over x. Because we have to plot the graph between p and 1 over x. And they mention which quantity should be there. Like here, plot a graph for p on y-axis and against 1 over x on x-axis. So as I mentioned already, that p should be on y-axis and 1 over x should be on x-axis. And the second thing, start both axes at the origin or 0, 0. So now it is compulsory that you should start the axis from 0, 0. You cannot start with any other number. It should start with 0, 0. So p is there. And the extension, the distance from that is in centimeter, 1 over x or 1 over centimeter. So the minimum value of x is, but we have to start, like it is compulsory that we have to start with 0, 0. So it should be like the first value should be 0. Then if I have this as 0.025, then this will be 0.050, then this will be 0.075. But this scale, if I select this scale, as you can see, this scale is not covering about like 70% of the graph paper. So I should increase the size. So if I select this as 0.02, this as 0.04, this as 0.06, this as 0.07, then this will be 0.08. So 10 boxes equals to 0.02. Each box is 0.002. On x-axis, numbers are there, so it's easy to plot. Like if I say this is 2, or this was, if I say 1, 2, 3, 4, and 5 will be there, I don't get 6. But if I plot in this manner, so like this one is 2, so this is 2, this one is 4, then 6, 8, 10. And if I want to extend the scale, example, if this is like, if I try to extend the scale, I won't get 6 there. So 1, 2, 3, 4, and 5. This is 1. Then 1, 2, 3, 4, 5. This is 3. And this one is 1, 2, 3, 4, 5. So this one is 5. Then 7 will be there. And then 9 will be there. Now, when we plot the result, when it is 2, 0.025. So each box is 0, like this is 0.022. This is 0.024, and this is 0.026. So between them is 0.025. So this is the first point. Then 3 and 0.37. So 3 and 0.37, because this will be 0.022, 0.2, 0.224, 0.2, 0.026, 0.028, and 0.03. This will be 0.03. This is 0.05. This is 0.0. This was supposed to be 0.08. This is 0.07. Now, the second value, 3 and 0.37. So 3 and 0.37. So this is 0.32, 34, 36, 38. So between them will be 37. So this is the point. Then 4 and 0.50, 4 and 0.50. This is the point. Then 5 and 0.63, 5 and 0.63. So this is 5, 0.62, 0.64. So this will be 0.63. And then 6 and 0.075. So 6 and 0.075. So 0.0727475. Sorry, this one is 0.077274 727475. This was 75. As they mentioned, you start your graph from origin. What student think that this word, like when they say start both axes at origin, what student think that they should start the graph line from 0, 0 as well? That is wrong. You don't have to plot, or you don't have to start from the 0 line. You just join the points which you plotted. You don't have to join from the origin. You just have to start the axis from origin. So this is the graph between the P on y-axis and 1 over x on x-axis. Is it clear, this graph? The next part, in this experiment, 1 over x max, like the maximum value of x, if the maximum possible value of x is 50 centimeter, calculate 1 over x max. So what they're saying, if the maximum value of the x equal to 50, we need 1 over x max. So how we'll calculate 1 over x max? That means we just have to take a reciprocal, 1 divided by 50. So using 1 divided by 50, we'll get the maximum value of x. And use the graph to determine the minimum value of P required to balance the meter rule, and show clearly on your graph how you determine this value. So how we determine this value, like we need the minimum value of P. So how to determine the minimum value of the P? So first 1 over x, the value of x is equals to 50. So 1 divided by 50 is equals to 0.02. This is the graph between P and 1 over x. Okay. The maximum value of the x is 50. So when we calculate 1 over x, 1 divided by 50, 1 divided by 50 is 0.02. So means if the value of 1 over x is 0.02, we want the value for P. That's the minimum value of a P. Like, so how we can determine? So if we just extend the graph, if we just extend our graph line, like this is our graph line. So what we will do, you have to show this on your graph. So when the value of x is equals to 0.02, what is the value of the load, minimum value of the load? That is equals to 1 point. 6 Newton. So this is equals to 1.6 Newton because each is 0.2. So 3 boxes above 1 is 1.6. So when we solve this, when we get the value for x, the value for x, 1 over x was 0.02. And when the value of 1 over x is 0.02, what is the value for p? That was 1.6. Is it clear, this part? Then in part D, in this experiment, the width of an object is slightly greater than the width of the meter rule. So when we explain how would you place an object Q accurately as possible on 90 centimeter mark. So what they mean here, like if you're looking at the meter rule from the top and you place the object, when you place the object width or object is much larger than the size of the meter rule. How I will be sure that I place this at 90 centimeter mark or the center of this object is at 90 centimeter mark. So what we will do, we will measure the readings before and after and take an average. For example, one of the reading is say 88 or another or 89 and another one is example 91. So when I take the average of the two readings before and after, that will give us the position of the center. So how we write this answer? So we will measure the value before and after the object and take an average to determine the position of center. So take two readings or take readings before and after the object. We will take average to find the center of object. And this will give us like the center of the object is at 90 centimeter mark. Like if I say there's another object placed here and the two readings are, there's another object placed here and the two readings, one is 20, another one is 24. Where is the center of this object? At which position the center is there on the scale? One of the marking is at 20, the other marking at 24. Where is the center? So how to determine the center? We just take the readings before and after and take an average of the two. So it will be 44 divided by 2, which is equals to 22. So the center will be at 22 mark. That's how we determine the position of center of an object. In part E, in this experiment, it is difficult to determine the exact position of the load that will make the rule balance. Explain why this is difficult. So what is the difficulty here? The main difficulty, because in this case, if we want to in experiment, it is difficult to determine the exact position of a load that will make the rule balance. Explain why this is difficult. So why this thing is difficult? Because the difficult to obtain a balance point, or the idea is that the rule might tip over when the load is placed on it. So that is the main difficulty in this experiment. And explain how would you find the best position of a load that will make the meter rule balance. So how we locate the best position? So we will estimate the position before placing the load. Like before placing the load, we will just estimate. Like if I say I have one of the load is 2 Newton, another load is 1 Newton, and I want to balance them on a meter scale or a meter rule. So the 2 Newton should be closer to the pivot and 1 Newton should be away from the pivot. So I can estimate the location, estimate the position before placing the load. Because if I start both of them with the same position, they can never balance with each other. So for these type of experiment, difficulty is there that difficult to balance a meter rule or a meter scale when load is placed on it. And to overcome this difficulty, normally we estimate the position before placing the load on it.